Hi, everyone, and welcome to this new session of the Vertica Unified 2022. Today, we will speak about in-database machine learning with VerticaPy. My name is Badr, Ouali, and I will try my best to explain you the differences of this library and the others and all the analytical capabilities of VerticaPy. We will follow the following agenda. First, we will speak about the data science challenges. When we deal with data science lifecycle, we have to follow different steps in order to put the model into productions. And it can be hard when we use in-memory technologies. And that's why VerticaPy and Vertica ML can bring a lot of value there. We will explain what we have out of the box in Vertica ML and what values we're bringing in the table with in-database machine learning and advanced analytical functions directly in the database. Then we will go through VerticaPy, like the Python front end that is relying on Vertica. We are pushing all the computations to Vertica, taking the advantage of the in-database machine learning, but using the Python layer for more flexibilities. Then we will go through the VerticaPy top features. VerticaPy offers a lot of advanced analytical features at the top of Vertica, and we will go we will see the main one, like moving windows, in-database machine learning, cross-validations, etc. Then we will go through the Q&A session. So let's start with the data science challenges. So when we look at the data science lifecycle, we can see different steps. The first step is always to understand the business. Then we can ingest the data and try to pre-process the data, explore the data, do a lot of data preparation, prepare the features in order to do machine learning. But when we think about machine learning, it's just little steps in the process because we have to prepare the data well. What I'm always saying is garbage in, garbage out, which means that if you're not pre-processing your data well, you will not get a very good model. So what we always say in data science is that 80% of the process is more about data preprocessing and data preparation. And that's why we need really to work in the database. Just imagine that you have to move the data out and then bring it in to do, for example, machine learning or over operation. You will have a lot of challenges to do it. And this is why, more than 90% of the data science project will not go into productions because we are moving the data too much and we cannot follow directly the entire data science lifecycle directly in the database. And if you look at the traditional data science journey, you can see that most of the data scientists will use an ODBC or JDBC connection to the database, and then they will extract a sample of data in order to work in memory. And then you can see many limitations because then you have to work with the memory of your computer. So you are limited by this memory. And then you are limited by the computational power of your computer. And most of the time you are working with one single node. For example, when you're using Python R. And even if you're using multiple nodes with Spark, you're still limited by the memory of your cluster. And then the last step will be also to deploy your work because you can work well on building, for example, a model using in-memory technology, but then you need to automate the scoring. You need to bring it in the environment where the data are located. And it can be very hard. For example, here in the slide, we can see that we are trying to deploy a random forest classifier directly in a SQL database. It can be very hard because you have to find like all the conditional statement needed in order to do it. But you can imagine use cases that are much more complex than that. Like here, we are dealing with a random forest, but if you're doing with a combination of different models, it can be very hard. And plus, it's hard to maintain because each time you will have to train the model again, you will have to deploy it, find a way to deploy it into productions. So most of the time we are working with pickles. We bring the data in memory and then we are doing the scoring, but this is not the right way to do it. And this is why we created in-database machine learning in Vertica. In Vertica, you can go through data exploration to model deployment. You can summarize your statistics. You can look at the different outliers. You can, for example, create a train and a test split. But also you can, of course, do in-database machine learning. And we are providing many algorithms like extreme gradient boosting, random forest, k-means, and over functions like over algorithms like logistic regression, linear regression. But when I say logistic regression, it's not just a simple logistic regression. It's a logistic regression with, for example, elastic net parameters. So you can play on the regularization technique, as well as for the linear regression. And you can also evaluate the model. You have plenty of functions to evaluate the model. For example, R-squared, RAP curve, cross-validation. You can use all these functions directly with a SQL statement or with a Python layer. And we'll speak about this Python layer a little bit later. And then you have multiple ways of putting your model into production. So typically, if you create a model in Vertica, it will be stored inside Vertica. So you can do the scoring inside Vertica if Vertica is your production system, but you can also move your model out using, for example, PMML or a special object of VerticaPy called the MEM model in order to bring your model in another system and do the scoring in another system. We have also integration with other technologies. For example, you can bring your Spark model by exporting them to PMML as well. You can bring also your TensorFlow model because typically TensorFlow can be exported to frozen graph. So we provide in-database machine learning and a lot of functions, but you can still use the tools you know and bring your work inside Vertica when you're ready. So here it is. You have a set of functions, a set of algorithms. You can import them like using different technologies, frozen graph, PostGeo, PMML, and you can also export them to PMML and MEM model. But if you're looking well, you can also use what we call user-defined functions. These user-defined functions are, functions that you can code in C++, Java, Python, and R directly inside Vertica in order to deploy your work directly in Vertica. It's one of the most powerful features available in Vertica because just imagine that you don't have, for example, a specific model, you're training it outside and then you want to bring it in and you don't have a possibility to use PostGeo, PMML, or frozen graph. You can still use user-defined functions in order to bring your work into production in Vertica. And when we say why Vertica ML, you can see here why with the example of the random forest. Because when you look at the random forest, like in Vertica, we are training, for example, and that's one of the specificity of bagging is that we can really split the work across the different nodes, making this technique really scalable. So you can imagine that inside Vertica, each node will train one tree, and even more, it can train one part of a tree. And then for each split, you can use the power of each node to compute the Gini index. Then Vertica can merge the result, and then you have a lot of different ways in order to export your model, for example, using PMML, MEM model, or binary format. And then, of course, you can import it to other Vertica databases if you have, for example, a production environment where you want to bring your model. It's quite easy. We have our own binary format also to do it. So Vertica provides not only machine learning, but also an entire model management system where you can play with models the same way you're playing with tables, which means that you can look at your model, look at the different parameters. Here, for example, we created 3 models. You can look at their size, when they are created, the schema, the owners, etc., etc. Then you can, of course, alter your model. You can rename them, change the owner, grant some usage to some users on the different models. So as I said, you're playing with models the same way you're playing with other relation like tables or views. And you have the possibilities of looking at the shape of your model, the version, for example, you can add in the name the related version, but you can also, for example, look at the different parameters, the coefficients, etc., etc. So you have everything needed in order to play with the models directly in the database without having to use, for example, binary object, Python binary object like pickles, and then send them to other users. You have everything needed directly in the database to play play with a model where the data resides. So when you have all this power, all these sets of functionalities inside a database like Vertica, when you have this architecture, this MPP columnar database, an idea can be to bring the easiness, the flexibility of Python at the top of it. And this is the concept behind VerticaPy, because if you look at Vertica, it's an MPP columnar database having a lot of functionalities like in database machine learning, a lot of integration like PMML, TensorFlow. You can even bring your own user-defined functions. It's secure, you know the data provenance, and you can, of course, attribute some privileges to users and manage all the security inside your infrastructure. And you're using, of course, this powerful SQL backend. If you're looking, on the other hand, on Python, like Python has a lot of flexibilities. It offers a lot of rendering capabilities. You have like, at the top of Python, you can bring Jupyter Notebook, and you have this easiness of creating models, of exploring the data. The idea of VerticaPy will be to combine the best of both worlds in order to not write, for example, thousands of lines of SQL query, but to use Python in order to generate the SQL needed in order to do to compute the needed function. VerticaPy will be this Python layer at the top of Vertica, which is, by the way, open source. So we have a lot of customers that are contributing to the API. And you can also, for example, if you need a specific function at the top of Vertica, you can still, for example, ask for help, raise an issue, and then we can help you to create, for example, the needed function for the business use case. So you have all this flexibility in VerticaPy in order to solve your data science challenges. So just to provide you an example of what's VerticaPy, let's use one of the most common functions, which is the describe method. If you're already familiar with Python, when you're using a pandas data frame, you have this describe method, which is quite powerful because you can see all the statistics of all the different columns in your data set. We have the same in VerticaPy, but the difference is here. You can connect using your credential. Here I'm using a DSN. And then we can create, for example, the vData frame of a relation. We will never load the data in memory. What we will do, we will just push the SQL computation directly to Vertica, which means that when I run the describe methods, VerticaPy will generate a SQL statement. Here, it's a select, summarize, num call of the different columns. You can see that it's a Vertica SQL built-in function that is not available with standard SQL. We have a bunch of this built-in function in order to simplify directly the syntax and also the computation, because this function will be more optimized than a select and then a bunch of aggregations like average and quantiles, etc. This aggregation will be sent to Vertica, and Vertica will send back the result on the user front end. And we can see how easy it is, because just imagine that you have, I don't know, hundreds of columns, and then you want to compute the aggregations of hundreds of columns. It can be complicated to write a very big SQL query, whereas with Python, you have this easiness of using methods and attributes, and then you can enter as input the needed parameter. Let's take another example. We take the same data set, but we want to compute the correlation matrix. It will do exactly the same. It will send a query. This query will use this function called core matrix. So it's another built-in function. It will compute the Pearson correlation function. The Pearson correlation coefficient, and then send it back to the user. But if we are taking something a little bit more complex than the Pearson correlation coefficient, if we're taking, for example, the Spearman correlation coefficient, this one is basically the Pearson correlation of the ranks. And the query is a little bit more tricky because yes, I have to use the core matrix function, but not on the set of variable, but the set of ranks, the ranks of a different variable. And you can see it in the query there. VerticaPy will generate the needed query in order to compute this correlation coefficient. And it will do the same for any functions you're calling. Then Vertica will compute the aggregation and then send back the result, and we get the correlation matrix of the data set. So VerticaPy provides like more than 700 built-in functions inside the API and is allowing you to follow the entire data science lifecycle, from data preparation to machine learning. If you want to have something approximately similar by using Python, you will have to combine three well-known API, which are scikit-learn, pandas, and StatModel. Because scikit-learn is providing machine learning and a little bit of model management. Pandas is providing a lot of functions for data preparation and some of them for exploration. And StatModel will provide like all the statistical tests, the time series model. But still, if you link the three of them, you are using different API, different functions, and everything can change every day. Because, you know, if, for example, one of the API is not maintained, then you will not be able to do, for example, a part of this data science lifecycle. But in VerticaPy, we are really providing all the set of functions in one package. Plus, we are providing some other features like AutoML in order to find, for example, a good relevant model for a data set. And of course, we are providing scalability because we are pushing all the computations to Vertica, which means that you don't have to load the data in memory, you don't have to downsample, and you don't have to find trick in order to build your model. You can build the model in all the data. As you can notice, we provide less algorithm than scikit-learn, which makes sense because with scikit-learn, you will have all the possible machine learning algorithm, even the ones that are not scalable. And the goal of VerticaPy is to provide scalable machine learning. So let's compare now the syntax between VerticaPy and pandas, scikit-learn, and StatModel. You can see that you will have approximately the same syntax for a lot of things. Here, for example, you want to ingest a CSV file. Inside Vertica, you can use our own read CSV function, which will parse the CSV file, identify the types, and load it in Vertica. We have our own train test split function in order to split the data into train and into test. And you can also see that you can also import your machine learning algorithm and then build your model. For example, here we are building a linear regression, and you can see that the parameters can be slightly different because in VerticaPy, you have to indicate the name of the model because it's stored in Vertica. And as I mentioned before, the model have a name, have a schema, and you need to indicate a name in order to store it in the system and then use the entire model management system, which is not the case with scikit-learn because with scikit-learn, you will have to pickle your models in order to share them. Then we can fit, and you can see that the fitting is a little bit different because here you are using the name of the columns instead of the entire matrices. For example, in Python, you will have to create your predictors matrix, which is the X capital, and then you will have to indicate a vector, which will be your Y. Here, as you're working with relations, you can directly indicate the name of the predictors and the response directly in the fit function using your training relation. You can also indicate a test set, which will be used in order to compute the different scores. For example, you have a lot of abstractions like rock curve, R squared, etc. And when you will use them, then all the computation will happen on the test set. If you do not indicate the test set, then the train set will be used. And you can see that you can use, for example, this test set in order to compute the predictions, use your model to compute the prediction, and then see the differences between the real value and the prediction, which will bring you your epsilon, and then draw a scatter plot of your epsilon. You can then use statistical tests. So you can see that with one API, you can follow the entire data science lifecycle without having to import a lot of Python, different Python package. Then when you're ready, when you did a lot of operation, for example, you can normalize your data, you can create over features. When you're ready, it's really easy to deploy because we are working at the top of a SQL layer, which means that then you can generate the SQL statement needed in order to deploy your work with just one line of code. Let's now see some of the VerticaPy top features. So VerticaPy provides many different features in order to simplify all the data science at the top of Vertica. And one of the most powerful functionality is the SQL magic function. So in VerticaPy, you can typically use Jupyter notebooks. And with these Jupyter notebooks, you have a simplified way of calling SQL directly in your Jupyter cell. You just have to create a connection. And when the connection is ready, then you can run your SQL query directly in the notebook. You can see in the example that I'm using the summarize num call built-in functions that I showed before in one of the slides before. And when you use, for example, SQL Magic, you can use the lines and the cell. Here I'm using a line, so you can write all your SQL functions using line of your Jupyter notebook. But you can also use cells, as you can see below. Here, for example, I'm using Pearson SQL, and you can use the entire cell of the notebook in order to send the SQL query to Vertica. But one of the amazing things in SQL Magic is that you can use variables in your SQL statement, which means that you can, for example, do a lot of operation with your virtual data frame, and then use your virtual data frame directly in your SQL statement. But even more, you can use, for example, your pandas data frame or any kind of variables directly in your SQL query. What Vertica will do, it will identify all the types of your pandas data frame, and it will ingest it in a temporary table, and then you can use it in your SQL query directly without thinking about how I can bring it to Vertica, which means that you can, interact between Python and SQL with a very easy way. You can even use, for example, loops or conditional, and then use your variable, again, the variable of your loop directly in a SQL, in your SQL query. Here, for example, I'm doing by hand a cross validation where I'm doing a loop where I create some train and test set, then I create a logistic regression, and then I'm computing AUC. And you can see that it can totally simplify the SQL usage compared to other SQL editors. One other fantastic integration is the one with Matplotlib and Highchart. Because in Vertica, when you use SQL, you don't have this possibility of having directly graphics. You need to connect to another BI technology. For example, you have to connect to Tableau or Click, or even Python, and then load the data in order to draw your graphic. Here, it's possible to use directly VerticaPy in order to draw graphics. And here, VerticaPy will not load the data in memory in order to draw those charts. It will push the aggregation to Vertica. Vertica will compute the result and send it back to the user. For example, a bar chart is just a group by statement. And you can see that you can do animated chart, proportion charts. You have all kinds of charts that are available directly in VerticaPy with just one simple line of code. And you can see one of the example using the Highchart integration. You can draw the chart using Python with the HChart function, or you can draw it using directly the HChart command, which is a command very similar to the SQL command. But this one will be to draw graphics using SQL statements. And those graphics are responsive, and you can also play with your graphics and export them if you need them in another environment, which means that you can use directly the JavaScript that is generated by the graphic. You have a way to export it, and then you can use, for example, the result of your graphics elsewhere. One other impressive feature in Vertica is Geospatial. Because we were one of the first database to provide Geospatial in database with an optimal way of computing the different operation. One example can be spatial joins. We have, it's one of a few times in Vertica where you have to use indexes. So you can create the index of the different polygons, and then you can look at the intersection of each polygon and each data point in your data set. And you can see that you can do it both in SQL and Python as usual. Compared to the other databases, here we have an optimal way to compute the intersection between data points and polygons. We are not using, for example, like other databases, a cross join to do it, which can be very expensive. We are using these indexes in order to not bring like a very heavy polygon in each row of the data set. We are really indexing it and fitting, like mapping the value at the last moment when it's really needed. And we are providing more than 70 geospatial functions. Like you can compute the convex hull, you can compute the buffer, for example, draw a circle around a specific data point. So you have everything needed in order to do geospatial at scale. And here we go. We have like another amazing feature, which like is used by most of our customers, because Vertica is a real-time series database with like a lot of time series functions. And one of them that you probably know if you're using Vertica it's time series joins. You can, inside Vertica, join two time series together by looking at the closest timestamp. So with other database, you have to slice by yourself, by hand, the time, and then join the different timestamp, which can be very expensive. In Vertica, you can do it with just one line of SQL or one line of Python, basically. You have in Python this parameter called onInterpolate, and then you can interpolate using the closest timestamp. Same in SQL, you have this clause, which is called interpolate previous value, and then you can join the closest timestamp together. Very powerful if you want to enrich the data and want to join different data sources. But you can also, if needed, slice the time and interpolate with the time series clause. You can see time series, and we have the time series aggregation like TS first value. So basically, just imagine that you have a regular time series and you want to slice it to regular steps. For example, here each for 30 minutes. You can do it quickly using the different clause in Vertica. And you have also this way of interpolating the values, because as you don't have a value, you need to find a way to fill it. And you have constant and linear interpolation directly in the platform. When you have all these functions to pre-process the data, like one idea can be, of course, to use in database machine learning. And inside Vertica, you have all the machine learning algorithm needed to pre-process the data. So in Vertica, you have many algorithms like extreme gradient boosting, random forest, k-means, naive Bayes. And we are implementing new one like ARIMA or isolation forest. We already have ARIMA in the system, and ARIMA and isolation forest will be ready soon. So you can see that we are trying really to provide the algorithms needed for any type of business, because, for example, ARIMA is really needed in case of time series. And we know that many use cases are related to time series, like predicting the traffic or predicting some stocks in finance. And isolation forest is a key algorithm because it can be used for anomaly detection. So you have, for example, a data set with a lot of numerical values, even categorical values, and you want to find the anomalies in this data set. Isolation forest can be, for example, a great fit. We implemented last year extreme gradient boosting, and we have, like as I mentioned before, a very scalable implementation of all the algorithms that we provide. So to create a machine learning model in Vertica, it's quite easy. You can just use a select statement, and then you just have to indicate the name of your model. Here, it's a logistic regression. You can see it. We are using different predictors, and then you can use the parameters. And here you can choose your optimizer, the regularization technique, etc. So very easy syntax, which can be used by data scientists or analysts. But if you're not familiar with SQL, you can still do it in Python, and the Python is really the Python syntax is really similar to scikit-learn, except that in the fit, instead of fitting, as I said before, X and the Y, we will use the table name and the predictor's name and the response name. Then you can have as result the different coefficients and some informations about the model itself. For example, how many iterations it did, how many were rejected, etc., etc. And then you can evaluate the model. To evaluate the model, you have many ways. In SQL, you have like all the functions that are separated, for example, R squared or AUC, etc. So in VerticaPy, you can use directly the classification report or the regression report. And then you can have all the metrics needed in only one report. It can be used, for example, in script in order to test the model every day and see if it's still, for example, accurate using the needed metrics. And you have also a lot of over abstractions. You can, for example, compute the features importance. Here, I'm computing the features importance of a logistic regression, but you have a very easy function to do it for a tree-based model. For example, you have for random forest a function called random forest features importance that you can use directly in SQL and then get the different value. In VerticaPy, you just have to use the features importance method, and then you get the importance of the different feature. And when you're ready to put your model into production, you think that your data preparation is fine, and then the model is predicting well. So sometimes you don't want to do it directly in the database for the scoring, and you want to do in-memory scoring. So in this case, we are providing what we call the MEM models. MEM models are like Python object which can typically do scoring in any in any system, as long as you have like as programming language SQL or Python. You can see them as, you know, this some scikit-learn object, but improved, because they already have whatever scikit-learn has. For example, a predict proba, a transform method, and they can score in Python, but they can also generate the SQL needed in order to deploy the work in over databases or over SQL environment. And they are great object to do, for example, real-time scoring, or to deploy to deploy your work in SQL over SQL environment. But typically, if you like, this is if you want to move the model out and do the scoring outside Vertica. If you want to do the scoring in, you have everything needed directly in the platform. So you have a lot of different functions like predict logistic regression, apply normalize. So those functions are for the built-in algorithms. But for the others, for example, you have functions to predict TensorFlow models, which will be predict TensorFlow. You will have a function for also predicting with PMML. So you can directly import your work to Vertica or just use the model that was created in Vertica and then do the scoring in database. So you have multiple ways to deploy your work into production in Vertica. To deploy it outside Vertica, I just mentioned the MEM model that can be used to import it to other databases, for example, or over Python environments. If you're using Flask, Django, you can still import VerticaPy and then import your MEM model and then do the scoring directly there. Otherwise, you have, for example, the PMML export. PMML is a great way to bring model in other environment because most of the environment are supporting PMML. For example, Spark, KNIME, SaaS are supporting PMML. So you can export any Vertica model to PMML and then import them in those environments. For extreme gradient boosting, you can also export it to JSON and then ingest it in the XGBoost API. It is a way to, for example, use their C++ implementation because they have this way of for example, saving a model using a JSON format with all the attributes of the model, and then you can ingest it and then use both of their API. And of course, you can generate a SQL script and then bring your model in over databases if you need to deploy your work there. So we saw some of the top features of VerticaPy and all the capabilities of Vertica ML. The goal of VerticaPy is really to provide one single API where you can do the entire data science lifecycle. You have inside VerticaPy a lot of ways to do machine learning. Also, you have what we call automated machine learning, which can be a great asset to search, for example, for a good model. But you have a lot of functions to explore, visualize the data, do a data preparation at scale, and a lot of algorithms that are available directly in the platform. What we want is really to give you all the tools to solve any use cases directly in Vertica without moving the data out and using the entire data set. So thank you for assisting to this first presentations. So we can switch to Q&A.